You may know them for their wood glues, but did you know TightBond also has a complete selection of construction adhesives? Designed for a variety of applications, TightBond's adhesives make any building or home improvement project a breeze with their high-performing and durable formulas. These adhesives are trusted by the professional, providing squeak-free subfloor installations, long-lasting retaining walls, and even fastener-free feature walls. Check out TightBond's construction adhesives at TightBond.com, including their newest award-winning adhesive, Tight Grab Plus.
Yeah, I don't want to cut this discussion short, but my answer is don't do anything. It's beautiful. Clean it up, leave it just as it is. Buy a big freaking heating system and enjoy the hell out of this house because it's gorgeous.
Welcome to the Fine Homebuilding Podcast, our weekly discussion of building, remodeling, and design topics aimed at anybody who cares deeply about the craft and science of working on houses. I'm Senior Editor Patrick McComb. Today I'm joined by Fine Homebuilding Editorial Advisor Mike Girton.
Hello.
Fine Homebuilding Senior Editor Brian Pontalillo.
Hey everyone.
And our producer Andres Samaniego. Please email your questions to FHBpodcast at taunton.com. You can find previous podcasts and check out the show notes at finehomebuilding.com/podcast. So before we get to check-in, I just want to briefly mention, y'all, since the acquisition of the Taunton brands by AIM, we're going to be changing our email address. It's going to be FHBpodcast at finehomebuilding.com. The old email address will work, but we're making a transition and thought you all should know. And frankly, it's a better email address, right, Brian?
Definitely, yes.
So FHBpodcast at finehomebuilding.com. I'm sorry, go ahead.
Yeah, no one really ever understood that. You know, you're talking to him. You're from Fine Homebuilding, and then you give him that email address, and what?
When I first started at Fine Woodworking, I heard the story of folks who were driving around Taunton, Massachusetts, trying to find the company headquarters, and we had to tell them that they were in the wrong place. How you been, Mike? Good to see you.
Yeah, been putting on muscle relaxants on my body because I'm so achy from raking and shoveling and all that kind of stuff. Oh, I've been doing landscape work around the house for a patio in the backyard mainly, but that also incorporates taking fill from the backyard, which it all sloped towards the house, so we're carving a way into a bank of earth and then moving that to the driveway to redirect stormwater. So it's a site-wide project.
I don't have much experience with landscaping, but one of the things you're doing had great appeal, and it looks like you rented a small loader backhoe. Do you want to talk about that?
Yeah, I rented I was hoping to get a mini loader backhoe, but they were out, so I got a micro, which actually works out better. I don't know how they classify a micro versus a mini, but this thing, it's just like the next step bigger than like a garden tractor, like a lawnmower garden tractor, but it's got the full front loader, which holds maybe like a quarter yard, like 9 cubic feet.
Like a good wheelbarrow, right? It seems
yeah,
like
it's like a big 10 cubic foot wheelbarrow, maybe a little more, 10 cubic feet, and then it's got a little backhoe in the back, and I found that it just fits everywhere. I can tuck it in, spin it around in like an 8-foot area behind the house without banging into the wall, which is good. And it's diesel engine and 4-wheel drive. And when I rented it, I said, "So you got any instructions for me to go over it?" And they're like, "Nope." Here you go. Oh, they did give me one instruction. See how much diesel is in the fuel tank? Bring it back with the same amount.
Yeah.
So I've been taking my phone and just doing YouTube videos on like how to switch between 4-wheel drive and 2-wheel drive, because you got to do tight turn radius. You don't want to be in 4-wheel drive because you just wear out the universals there.
And you tear up the ground, right? You tear up the tracks and the grass.
Yeah. So
not where you are, but
yeah, right. In the dirt. But yeah, it's been working out.
You know, the moment I saw this thing, it occurred to me, I see one of these in your future. That would seem like it would be very useful around your property in Arizona. Have you thought about buying one of these?
I had thought about buying one because I have a full-size backhoe, a couple of them at home, and I use those regularly. And I've been, considering getting a small one just because sometimes you don't want something that's, 80 feet long and, spinning around, and it's just awkward to fit, especially around your house. So I have more than one smash things that I don't want to smash, like my pickup truck. So I, looked into buying them, but boy, they're so expensive.
Is
They're
it what,
like
30
crazy.
grand, right?
Yeah.
Yeah.
So I've been looking for used ones, and they're 28 grand. Like a 4 or 5 year old. They do hold their value, so I guess that's a good thing.
Well, it sure is pretty, and I would sure rather spend 30 grand on a little backhoe than I would on a Honda Accord or Camry or some other silly thing like that. What are you
Hey,
been
I
working
have
on? Go ahead, Brian.
Yeah, I have a question. I have a question for the podcast today. So this one of the things that I'd like to do this spring, I've mentioned this before, is build a shade structure so that we have a very exposed yard, and I want to have somewhere to put, an outdoor table and some seating, maybe the grill, that kind of thing. And so, essentially, I want to build a big pergola to create some shade. But I also want to make sure that I am designing a pergola that actually creates enough shade, right? Because if it's if the pergola is just really wide open, it's only going to give you so much shade. So I've been looking at different designs, and I have some ideas for like a slatted wall on the south and west sides of it, so that just keep where the hot sun is really beating in the summertime, I can block it a little bit. But I was looking at designs online this week, and I found one. It was sort of a more modern looking pergola where the rafters didn't overhang the top of the beams. They died into the beams. And I noticed that the rafters were on an angle. So they weren't straight up and down, they were angled. And I thought, that's brilliant, like, because if I angled them towards the sun or away from the sun, depending on where you're looking at it from, I'd create more shade. But then I started to wonder, well, how am I going to fasten those? I thought, like, you could put dados in the beam, but I don't know if that's a good idea in a structure.
Why can't you just go through the beam into the end grain of the rafter?
Go through the beam with what? Structural screws?
Yeah.
You think that's enough?
Well, you're not putting sheathing on it, right?
No.
And you're
So
not
what's
gonna
the
walk
load?
on it.
Yeah.
All right, easy answer. I didn't know it was going to be that easy. You guys are supposed to make things hard.
Well,
Yeah, 'cause you don't
give me a
want- you
minute.
don't
I
wanna-
can complicate anything.
Yeah, and you definitely don't want to put joist hangers because those would look ugly. You'd
Right.
see all those. Even some of the nicer looking ones probably wouldn't go with that clean line aesthetic you'd probably be going for with the design. Yeah.
I want to know
So
what
just-
rafter square has tables on it for cutting rafters at an angle that aren't vertical up and down. That's going to be a challenge,
So just structural screws.
Well, you know what? Even better than structural screws plural. Just do a single one from each end and long, and then
Yeah.
you could actually rotate. If you put it dead center, you could rotate.
Yeah.
Oh my God, that's brilliant! Like a shutter.
Yeah, exactly, like a shutter. Oh, and you could put one like keeper down the middle, so that just like a shutter, you could slide it left or right, and all of them move at the same time.
I
Now,
can
this is
imagine
the
the viral video now, Brian. It's going to
Yeah.
be what makes us all rich. This is fantastic.
This is the complication I was looking for from y'all.
Of course, you're going to have to find some lumber that isn't going to twist and warp in order to, you
Oh,
don't
yeah.
want southern pine pressure treated. You're going to need some nice redwood or red cedar up there.
I think you
Yeah,
got to cast
it's
your
gonna
own
be a long
fiberglass
span.
rafters while you're doing this. It's going to be great. Andres, what have you been doing? I've understood you've been killing it on production of video and audio. I'm guessing that you've probably had less time to work on your house. How's that going?
Yeah, I've been only working on my house on the weekend and late night. But I was just trying to finish my bathroom. But now I can relax now that it's done. I just need to do some electrical work, change some outlets, and then that will be it. But my next project is actually I'm gonna be painting my kitchen cabinets this spring. So I need to prep my my garage to do that. Since it's not insulated, I need to insulate it and make it a shop, pretty much.
Sweet. Boy, that is a fantastic excuse to build a shop. I guess that was how you sold it to the family, right? Because we got to paint the cabinets.
Oh, yeah. I need my shop.
Have you seen his inflatable spray booths? I've often needed an excuse to buy one of these things. Do you know what I'm talking about?
No.
So it looks like a bounce house, right? That you'd buy from or rent from a, party supply house, except it's got clear plastic walls, and you can do painting and prep inside it. And I first saw them, I think Brian's mentioning at the Home Builder show is the first time I had seen one. But now in the kind of like auto repair genres I follow on YouTube, it's constantly being advertised to me. But you need one of these too. Tell the family it's going to save you enough money that it'll pay for itself. That's always the tactic I use.
Oh, cool. I'll take a look at it.
Yeah. You guys know what I'm talking about? Mike, Brian?
I haven't seen
First
it.
I've heard.
You need
Yeah.
one of these too, clearly, right? Well, speaking of cool tools, I got to tell you guys about something. So I've been working on my outdoor landscape lighting, and, every wiring project I ever take on takes more cable than I can ever think it's going to need. So I've had to make some splices, which is not ideal, but it did prove to be a good excuse to buy some new tools. So for starters, I bought this amazing assortment of crimp connectors that were advertised to me on Amazon. And look at that. Oh my God. I'm a sucker for anything that comes in a divided box. And these little connectors are pretty enough to look like bonbons, right? Got different colors.
Edibles. Now, how long do you think it'll take you to use all of those up?
5 lifetimes, Mike, but I'm going to need it, or I'm going to have them whenever I need them. And I've actually used them twice now, and I couldn't have guessed. So, but the best part is that they have a sealant in there, so when you shrink them, they have insulated covers over the metal connectors, and you hit them with a heat gun or a torch or a lighter, and it shrinks it around the wire to theoretically make it watertight. So that's cool enough. But then the even better part are these amazing ratcheting style crimpers, and they won't release unless you've given a full crimp. And boy, it's way more settling, or you feel settled when you crimp versus you don't know with a normal tool, a crimper tool, if you've crimped enough or too much and damaged it. So this kind of makes it foolproof, and they're beautiful too, right, Brian?
Now, are those sold separately from the actual fittings?
Yes. Yeah. So the box of fittings was about $50. I think the crimpers were 20 or 25, maybe 30. And then this is almost as cool. So this is 4-to-1 heat shrink tubing. Look how pretty that is. And you can slip that over the wires, and then once again hit it with a heat gun or a torch, and it shrinks around to make a watertight insulation around the connection.
Well, after you haven't used them up in 2 of the 5 lifetimes, then let me know, because I'll grab some from you before you end up throwing them away.
I think you should bring your wiring projects over here, and we'll make a weekend of it. It'll be awesome, yeah. Well, I think we should get to the show. Thanks again to listeners who have written in with questions or feedback. Really appreciate it. It makes the show what it is. This comes from Michael. Hello, podcast. I'm curious about your take on a recent Freakonomics podcast discussing construction in America. One point they bring up about halfway through the podcast, around the 31-minute mark, is on prefab homes. I've always found it interesting that most products in our world, from phones to cars, have standardized, mass-produced models, while home building largely remains a custom, individualized process. As a millennial facing challenges in purchasing my first home, it can be disheartening to hear about older generations owning multiple rental properties. I'm hopeful that more affordable prefab homes will become available. Here are some companies that I identified. He has vbc.com and unityhomes.com. I'll put links to those two on the podcast page. We've talked about Unity a number of times. I'll also put the podcast he's talking about. What do you guys think about this, Mike? Is he talking about you owning more homes than he can afford?
Well, I heard the podcast a couple months ago or weeks ago, I forget, and I actually thought about, and I might have even emailed it to you, but the podcast, you always talk to people. They always interview people who are pro something in these podcasts, not necessarily this one, Freakonomics, but other ones, and then you're just scratching your head like, they didn't talk to me. Why didn't they call me? Because, or you, or anybody who's like actually in the business on the other side who might be skeptical of what they're talking about. So, yeah, I don't see, widespread fabrication of homes in the United States. You got to figure production home builders have got it worked out where they've got the crews and the subs that are just moving along down the street as each unit goes up. So they just flipped the model of production homes in that instead of fabricating them in a factory, they fabricate them, they move the workers. And they've been doing this for 50 years. No, 70 years.
And it's very much an assembly line type operation.
Yeah,
I think you'd agree.
It is. And custom homes is just not a market for manufactured homes of any sort, whether they're modular or HUD code. It's just some people want a custom home. It wants to be very unique, and that's what they want. And you're just not going to be able to factory fabricate that efficiently, economically.
What do you think, Brian?
Well, I think you just pointed out one of my first thoughts about his note, and one of them is that that we it might just kind of point to this out that most homes actually aren't custom, right? Most homes are built by production builders, and they have a handful of plans at the most that they build, and they're cranking through neighborhoods, building the same houses over and over and over again. And so they're not. Most homes aren't custom, and they are. You guys actually just said it. They're actually built in a very production style, right, where the crews are just moving right along through the neighborhoods. And I think that, when you can move that to a factory, and there are definitely benefits that I don't think the benefits that get touted a lot about factory built homes, like quality control and resource efficiency, and I don't think they're inherent to working in a factory. You could do that stuff on a job site. It's not that you can't be, have great quality control and be resource efficient on a job site. You totally can. One benefit is that production doesn't slow down in inclement weather. That's kind of true. But then you add the cost of moving these components around, and so why does factory built housing never catch on? Well, for one thing, that it's not totally true that it doesn't, because a lot of the country lives in
HUD homes.
HUD homes and trailers, and and they're factory built and they're rolled onto the job site, and so it has caught on in a lot of the country, and that is the way a lot of people live. But what we've done with custom homes is essentially just moved the same process from the job site to the factory. We're not building them different in the factory, really. We put panels together, and then we have to assemble those panels on site, but they're stick framed walls, and the insulation's installed the same, electrical's the same, plumbing's the same. So I've always wondered, like, will factory built housing stick framed, or will factory built custom houses catch on when someone invents a different way to build a house? That's not just the same way to build a house, but instead of being done on site, being done in a factory. So you're asking a whole industry to change the way it works when it's actually working pretty well. Yeah, quality control in production homes could be better, and probably in a lot of custom homes, quality control could be better, resource efficiency could be better. These things are true, but you're essentially taking what builders know how to do and saying, well, why don't we do it in a factory instead?
Mm-hmm. What always drives me crazy in these conversations is the productivity of the American home building workforce is always mentioned, that as productivity has gone down over the decades. But if you look at the houses we're building, they're way bigger, way more complicated than they were in the 50s and 60s when they're comparing the efficiency numbers. And that is never part of the discussion, and it just drives me crazy because it's a gross oversight if you're not talking about that.
Yeah, when Larry Hahn describes framing a house in a day with his brother and moving on to the next house the next day, they weren't building 3,500 square foot McMansions with crazy roof lines.
Exactly.
Yep.
And the energy efficiency requirements are much more stringent now. We do a much better job with water management on the exteriors of homes. Yeah.
The interior finishes that people select between flooring and cabinets and countertops and fixtures are, the selection is infinite, and you got to put all those things that the customers select in the house, so everything's super customized. Yeah, it's a tough nut to crack to get put it into a factory.
Andres, what do you think about the prospect of manufactured or panelized or modular homes as a solution to our expensive housing?
I think it could be a solution, but not the solution. I don't have much experience with this type of construction, but I do understand the point of that Brian is making. Is pretty much just taking construction and taking it to a warehouse and building it there.
Well, if y'all have thoughts on modular panelized houses and their suitability for your business model, I would love to hear about it. Oh boy, so one of the great things about hosting the podcast is I do on occasion hear from folks from the past of other jobs I've had and people I've met in the housing biz, and it was delightful to make contact with Will of Turnkey Builders, because his dad, Eric, was a customer of mine at Rice Lumber Company in Shelburne, Vermont. The family's been home builders for decades now, and Will is in the process of working on a project, and he wrote to the podcast about our thoughts on insulating this house, and it has an unusual construction method, and I'll read his letter and then we'll talk more about how this house is built and Will's plan for improving its energy performance. He writes, "Hey Patrick, I hope you're well. I have a question that may warrant further discussion by y'all on the podcast. I have a house that's being turned into a duplex for two sets of couples who purchased this house with a large tract of land to farm. The main purpose of the build is to get two livable, comfortable, durable, healthy, efficient units. The owners are adding a lot of sweat equity to make this build happen on a budget, like hand mixing 30 bags of concrete this past weekend for new footings so I could roll into some structural repairs at the beginning of the week. Here's how the house is built. It's an 1836 farmhouse in Climate Zone 5, Jericho, Vermont. The exterior siding is wood. It is okay, and there's no need to replace it at the moment, aside from a few problem areas. The interior's been gutted back to the studs. There was no existing insulation. There are a few posts, corners, and intermediate along the eave sides, but generally the structure is comprised of 3-inch plank timbers stretching from the bottom plate to the top plate at the roof edge. These timbers are what the siding is hooked onto. Building or tar paper is unknown, but you can see daylight out in spots when looking from the inside toward the outside. We're trying to minimize spray foam as much as possible. So here's my question. I have two approaches to insulating this house, both of which I believe could work, but I'm curious if I'm missing something. I'm thinking until the siding is replaced and there's proper air and water barriers installed on the outside, we need to be prepared for some moisture getting into the wall and so it can dry. Approach 1 is to insulate the interior walls with continuous 2-inch Comfort Board 80 rock wool insulation, and then stand up 2x4 walls and install R15 cavity insulation in them. Approach 2 is to insulate the walls with dense packed cellulose before installing the 2x4 wall, adding a layer of tar paper to the wall so any water that gets past the siding doesn't impact the cellulose. I'd keep the 2x4s away from the exterior wall play about 2 inches to maintain a thermal break. Okay, what do you guys think? First off, we should talk about how this house is built. It's rather unconventional, but I have heard about this in other places, especially in New England. Mike, have you run into this before?
I haven't, but it looks interesting. It kind of looks like what year did he say it was built? 1836. So that's right at that period of time where you were switching from a hand-hewn post and beam timber frame to sawn lumber with water-powered mills. So you could see that the joists and the beams, some of the beams, were sawn rather than hand-hewn, which had been the way to saw up wood or form it into shape prior to that. So it looks kind of like a timber frame / balloon frame, but using those planks on the outside. I've never seen it, but it looks fascinating and difficult to work on.
And the planks are enormous. They alone are worth the price of admission. They're 3 inches thick, 20 inches wide, and go from the plate to the eaves. So, and that's
Yeah,
the
I don't.
glass. Yeah.
Yeah, I don't want to cut this discussion short, but my answer is don't do anything. It's beautiful. Clean it up, leave it just as it is. Buy a big freaking heating system and enjoy the hell out of this house because it's gorgeous.
Well, they could. Speaking of that, I agree with you, Brian. They could take the siding off the outside and do all the work on the outside and leave all of the inside exposed. Yeah,
Yes,
that's a good idea. That's a really good idea.
Well, Will.
That's approach number 3. It's not listed there.
I'm not a big fan of spray foam, and spraying foam on these gorgeous wood boards just kind of makes me twitch a little bit. But boy, it does seem like a good solution for this particular project. But if you're not willing to go that, I think that the felt paper and cellulose is the way to go. At least it's reversible, unlike the foam.
Yeah.
What do you guys think?
I agree. I totally agree. Although I am serious about leaving it.
What do you think, Andres?
Yeah, I would leave it too.
You'd leave it too.
That rustic.
Option 3.
The new styles now kind of have like exposed beams, but this has exposed everything. Kind of looks good.
You could Larson truss on the outside, right? Take the siding off, do a Larson truss. That way it gives you an opportunity to run all of your utilities, wiring, and so on the outside. Dense packet on the outside. Save the siding if that's, something that they want to save and reuse. Just take it off and then put it right back on over after it's after you put up the Larson trusses.
Well, Will, I think you got Mike and Brian willing to come up and help you with this project, so I would totally hit him up for that. Will has a couple additional questions here. He says the basement or crawl space has all the things: stone foundation, CMU block foundation, poured 4-inch thick slab, a mud slab / rat slab with cracks, exposed dirt areas. I thought originally about wrapping the space with impermeable membrane, but after reading some articles by Martin Holliday and Andy Engel, I landed on the following approach. My plan is to put rigid foam on the CMU block sections with tape seams, mortar joints in the field stone, and then paint with dry lock. Install plastic over the floor of the mud slab areas, maybe then add horse stall mats to have a workable surface on the plastic. Install a commercial grade dehumidifier like the Santa Fe 70 in the space. Boy, I think you got that dialed in, man. I would say that the Thermax, which is a polyiso, has a foil barrier on it, and oftentimes you don't need to cover that with an ignition barrier like you do with the foam type insulations. Any other thoughts, guys?
Well, just that the stone foundation is a place where spray foam, closed cell spray foam, can come in handy. It's not a material that I prefer, and I definitely don't recommend it for use often. But that's one of the ways that a lot of those stone foundations are handled in the New England area anyway. And I think it's a viable solution there to get some insulation value on the stone.
What do you think, Mike, about that?
Well, he doesn't mention. Well, I agree about the spray foam, but he doesn't. Will doesn't mention if there's any moisture problems that he's noticing down in the basement, and if there are, Joe Stiebrick and Steve Basic have both written things in Fine Homebuilding or BuildingScience.com about the old stone foundations and how to deal with them, because they're particularly leaky. And it's to put in an interceptor layer on the inside, which is basically either a peel and stick material, even better, just a dimple mat, down to a drainage slot down at the slab area, and that way, if anything does come through. But one thing you could add, I would definitely add, no matter which approach you take to dealing with both the CMU and or the stone portion, is take measures on the outside. Make sure it's graded away from the house, the sloping grade, no puddling, downspouts if there are gutters. Make sure those drain way away from the house. And my favorite, an underground gutter system. Just put a perimeter of plastic or EPDM or PVC, something durable down several inches below the grade, or just maybe 3-4 feet out, and that will reduce any moisture pressure, as well as keep the whole place a little less humid in the summertime.
Folks who live near Will in northern Vermont are going to make the observation that whenever the cows move out of the dairy barns, the stone foundations under these buildings are often compromised because the cows keep the space warm and prevent spalling and frost movement that pretty quickly starts to make these barns wonky and the stones break down. Is there any risk if we're insulating on the inside that heat that is keeping the stones from freezing on the exterior side is going to then freeze during the wintertime and break the stones apart? Are we worried about that? You're shaking your head, Mike.
I don't think, unless there's a lot of water getting saturated soils against the building that are going to freeze and transfer that the potential for the rocks to expand and crack. As long as the mortar joints or you got a good parging coat on the outside of the exposed area, you should be okay. I could be completely wrong. But my neighbors have a house that is got a stone foundation. I worked on it over the last 50 years on and off, and they don't have any sort of real heat source down there because of they insulated the floor between the basement area and the living area, and it gets really cold down there in the winter, and there's you can see daylight through some of the mortar joints, and aside from the mice, they don't have any problems with the stones or the mortar. The climate is, of course, in southern New England not like they get up in Vermont, so.
Oh yeah, it could be 20, 30 below for a few days or a week at certain times.
It's a good idea to always consider. Emily Mottram wrote about this in an article in the last issue on building science mistakes to avoid. Once you bring a space into the thermal boundary of the house, it's a good idea to consider conditioning that space. Basically what she says is that once anything that's in the thermal boundary of the house, whether you bring an attic space, maybe you turn an attic into living space or an office or something, so you bring the insulation up from the floor to the roof plane, or whether you take an unfinished old basement and start insulating it and bringing it into the thermal boundary of the house. At that point, it's worth considering how you can condition it. And so with basements in this climate, I think that often means, bringing some heat to that space in the winter time. It keeps the building healthy. Mm-hmm. To do that. And, basements are such an interesting part of, in older houses, not anymore, because hopefully not anymore if we're building properly, but in older houses, basements are such an interesting part of the house, right, in terms of the envelope or the enclosure, because often we just stopped the thermal boundary at the walls or maybe at the rim area, and then just left the basements like this sort of nebulous space. They weren't outside, we didn't insulate the floors, so they weren't outside of the thermal boundary, but we didn't insulate the basement, so they weren't inside the thermal boundary either. And so now, we're starting to learn that it makes sense to bring them into the thermal boundary, so it also makes sense to condition them.
Well, Will, I hope you'll invite us to the wrap party when you finish up this project, because I can't wait to see it. And maybe leave what do they call it? A witness window, right? A little space on the first floor that you can show folks the board construction of this house, because anyone who builds houses would be completely fascinated to see that. I am sure.
Yeah,
I'm sure.
It is stunning. Hey, can I let me ask another podcast question for the podcast or for our listeners, because it just came to as I was speaking, I just realized that the building codes require a crawl space that's within the thermal boundary to be conditioned. So why isn't the same requirement for a basement?
Well, isn't it assumed to be conditioned? I mean, generally speaking, the heating plant is down there, and why wouldn't you put it there if you had a basement, I guess is my question.
And so just by having it down there, that's assumed to be just by having the the boiler or the furnace running in the basement, that's assumed to be conditioned.
Well, now you make it sound silly, so thanks for that.
I'm actually curious because I actually, like I said, I just thought of that while I was speaking about it.
I don't know what the code is exactly on crawl spaces, so I don't know how that would translate. Does the code say you have to condition your crawl space, or you have to insulate it?
It says that if you choose to have a sealed crawl space, so essentially bringing the crawl space into the thermal boundary of the house, you have to either have supply air from your heating cooling system into the crawl space, or you have to have registers in the floor, vents in the floor, and be exhausting air with a fan continuously from the crawl space, which is essentially pulling conditioned air into the crawl space from the house.
So, interesting. So if you have a vented crawl space, you don't have to do anything.
Right.
But if you seal the crawl space, then you have to do all these other layers.
Then you have to condition it, yeah.
Whereas with a regular full height foundation basement, there's none of that requirement. Oh,
I don't believe so. Yeah.
Yeah.
Well, folks,
so anyone who knows about that,
please write in with your thoughts on that.
That could be a good know the code.
Yeah.
I'm writing that down, Brian. Of course, that's your department. You write that. What a great question, Will. And, I don't know if that was helpful at all, but I'm sure grateful you sent us those amazing photographs of that house, and I wish you great success with that project and everything. Thank you. And tell your dad I said hi. This comes from Kurt. Hey, podcast crew. In a few months, we'll be doing a seismic retrofit and crawl space / basement encapsulation. This is your word, Brian. Of our 1905 two-story house in Seattle, climate zone 4C. I wrote into the podcast about a year ago, episode 560, regarding the seismic work, and finally came to my senses to just hire out the project. The house currently has a vented crawl space and an electric-resistant hot water heater, which is 3 years old. There's also a high-efficiency gas furnace, both of which are located in a deeper but still unconditioned portion of the crawl space. I'm curious about your thoughts about changing the existing water heater to a heat pump water heater. The dehumidification benefits help after the encapsulation is complete, but I'm concerned about the temperature drop and overall efficiency. The crawl space is roughly 1,100 square feet and will have continuous interior foam on the pony walls, but none on the floor. The annual average ground temperature in this area is 47 to 52 degrees, but it's certainly warmer in the summer months. The underside of the first floor currently has fiberglass bats, which are disgusting and will likely need to be replaced with timber HP bats after finishing the encapsulation. I plan to do a little heating into the space via existing ductwork. Will a heat pump water heater make our main floors cold? Anything is certainly going to be better than it has been with a vented and poorly insulated floor. I've read through a number of articles on GBA, Energy Vanguard, and other sites. Energy Vanguard suggests that the temperature will drop on average 2 degrees from the heat pump water heater. One paper from the University of Maine suggests an 18% energy savings if switching to a heat pump water heater. Given the rebates and tax credits, it seems like a good time to consider this work. Our Emporia Energy Monitor shows the current water heater is using 30% of our total electricity. Our bills vary between $100 and $450 depending on the season. What's my best choice here? Should I locate the heat pump water heater in the basement and have it ducted outdoors? Should I exhaust it outdoors? Should I stay with the resistance heater do I replace the bad insulation? Should I save some money here and switch the gas furnace to a heat pump instead? For some additional context, our blower door test prior to any upgrades was off the charts, and they were unable to reach an ACH 50 pressure. Since then, I've done considerable air sealing in the upstairs knee walls, attic, and which is now insulated to R49. I've also sealed up the exterior walls, but have not done any blower door directed air sealing yet. I believe the encapsulation project will both improve indoor air quality and reduce the stack effect significantly. Our energy bills vary between $300 and $600 per month depending on the season. What did I read that already?
No,
I
he
guess that's
repeated
heat
it.
of gas, right? Yeah.
Yeah.
Yeah. Sorry for the long email, but I thought the context was important. Any advice is welcome as usual. I've attached a photo from the upstairs knee wall air sealing and insulation project from this summer. I calculated that I enclosed about 50 square feet of open joist space. The floors are a lot warmer this winter. It was uncomfortable work, but definitely worth the effort. Oh boy, what a great question, Kurt. Okay, so there's a lot to unpack here. First off, why do you hate the word encapsulation when describing crawl space, Brian? Let's start with that.
Well, I think this is a good example, and I hope that I don't have this wrong, because I don't want to be calling Kurt out, but I don't think he understands what he's trying to do with this crawl space. And the reason I say that is because he's talking about encapsulating the crawl space but leaving insulation in the floor. And the idea is there's two ways to approach a crawl space, and this is what we were just talking about. Either bringing it, either isolating it from the thermal boundary and in the air ceiling of the house, right? So you have in which case you would have a vented crawl space. You would have your thermal boundary and your air sealing at the floor of the building, and then the crawl space would essentially be outside. You have to have the appropriate amount of venting, but your crawl space is now outside of the house. And the other way to approach a crawl space is to have a sealed, conditioned crawl space, which is to bring it into the thermal boundary of the house and into the air barrier of the house. In which case, your thermal boundary and your air barrier continue from the walls of the house down the walls of the crawl space and across the floor of the crawl space. So he's talking about both bringing heat to his crawl space and insulating the floor of the crawl space. These things don't make sense. I think what he wants to do is, what he wants to do, especially because there's equipment down there, is to bring this crawl space into the thermal boundary of the house. So to air seal and insulate the crawl space itself. Then he can condition the crawl space. Then he can have his mechanicals down there and they can run as efficiently as possible.
Mic drop. Boom. You've been nodding with great agreement, Mike. Any thoughts to add, or why do you like Brian's plan?
I like it because it meets the code and it goes above the code. No, so with any sort of thermal boundary, you want to define where it is, and he wasn't defining the full thermal boundary. You would either do, with a crawl space, you either do the floor, the first floor joist bays, or you do complete you do the walls and the floor of the crawl space, so it's part of the thermal
space.
Boundary. And so he didn't describe the doing the floor separately, because he pointed out and he understood that if he put his heat pump water heater down there, he would have potentially cooling that area down, and now this floor would get cold. So he wasn't intending on insulating that. So do it one way or do it the other, but you got to do it. Do the floor and the walls, or do just the floor joists.
Is there a better material than 6 mil poly to create a vapor retarder or vapor barrier on crawl space walls to stop vapor drive? Should you use the reinforced stuff? Should you use these very thick 20 mil products? Have you had any experience with one or the other product, Mike?
No. I mean, I've used them for other things, but I've not done any crawl space work where I've done it up the floor and up the walls. I haven't done that work.
I think it's a durability issue, right? So if they're going to perform the same. They're both, they're vapor closed, no matter, so that once installed, it's going to perform the same. I guess the question is, can you get it installed without damaging it? And are you going to is there potential for damage once it's installed? And if there is, then you might consider a more durable product, a reinforced product, the Stego product, Mm-hmm. But if you feel like you can get 6 mil poly down, without damaging it, and no one's going to be going down there and working on anything once it's installed, then it's going to do the same job.
Mm-hmm. I'm going to put an article that I did early in my fine home building career with Jeff Tooley when he went to great efforts to air seal a crawl space in a home in North Carolina, and It was one of my more challenging photo assignments, but I tell you, it was a pretty solid content as article as a result, and still very proud of that. And Jeff, thanks for your help with that. If you're listening out there, do you remember that piece, Brian?
Oh yeah,
Yeah.
yeah, it was excellent. I think it's a good one to reference for this.
It's it also reminds you of how gross this work can be.
Yeah, no doubt. But to Kurt's other question about putting the heat pump water heater in that crawl space / basement, I think it would be fine.
It makes a lot of sense, right? Because it's going to help
it does.
dehumidify that space, which is likely to be cooler than the rest of the house.
Yep. Indeed. And even though we might think that the floor is going to be cooler, it's going to be part of your conditioned space if you do as Brian suggests and do the whole slab area. Then that would mean that the heat pump water heater is scavenging heat from the heating system of the entire house. So as long as there's air circulating through there, it'll be tempered by your upstairs air. In other words, your crawl space isn't going to be 47 to 52 making the floor cold. It's probably, if your upstairs air is say 70 degrees, your crawl space will probably be like 65 degrees or something like that. A lot of the high performance builders, building passive homes, they're putting the heat pump water heater right in the living space of the house, like under a staircase or something like that. And it's, in the wintertime, it's pumping out a little bit of cold air into the living space, but you're counting on the heating system of the house to be warming that air as well. So it does work, and it is more efficient than a resistance-only heater. Of course, it does depend on your electric rates, and I understand that the Pacific Northwest has some pretty inexpensive electric rates, so I don't know how all that would equate out. You'd have to do an energy model based on your electricity use to see what the payback period would be on a heat pump water heater, but it would go region by region based on the electric rates that you're paying.
I would say, even if you're not planning to do it now, make a plan for when you inevitably have to replace the resistance heater, because when you're in the throes of having no hot water, you're going to put whatever is easiest in there. And if it's going to be easier for your plumber or yourself to put in a resistance heater, that's what you're going to do. So
Yeah.
if you have a plan to replace it with something else, do that ahead of time. That's a great question, though, right, Kurt? Or thanks, Kurt, for that. That's a great question.
Yeah.
This comes from Evan. Hey, FHB crew. It's your North Carolina friend, Evan, here again, working on his old house. I love Evan. Evan's got a great project going. Hey, a previous owner installed an equipment pad and basic connections for a washer dryer in the dugout section of the basement of this house. There strangely was no dryer vent, so I ran a duct and attached it and ran it to the outside. This is not where the trouble ends. I installed the washer and directed the drain to the existing standpipe shown in the photos that terminates about 6 feet above the equipment pad, and so it would drain back down to the sanitary main that is about 3 foot lower. I came downstairs after running a load to find the whole basement floor wet and the washer with dirty water on the clothes. After disassembling part of the drain, I found it to be clogged with a bunch of semi-wet, semi-solid material. Putting the shop vac to the end of the drain and holding it there brought most, if not all, the gross stuff out of the drain, which I figured was clogging it. While running another load of clothes after doing this, I sat in the basement and watched the machine work. When the cycle went to drain, everything was fine for a moment, but then all of a sudden water started pouring out of the top of the standpipe again. If I don't have a clog in the pipe, what could be causing this issue? Is the drain not properly sized? Could there be a clog in the next pipe? Can a washer not work from being below the point of draining? Any solutions or insight would be helpful, as I'm not sure how the previous owners made this system work. Thanks for your advice and countless hours of listening. Evan, I'm going to go first because I have a little experience with the old habitat houses I worked on. So if you go back and think about the context of when these homes I was working on were built, there was no washing machines. They were added after the homes were built. Oftentimes, they don't even run to the sanitary sewer. Somebody would dig a hole in the background, fill it with gravel, and it was assumed that running the washing machine into this dry well, as it was described, was a great way to get rid of the water. And I think folks who are into gray water recycling would suggest that it is indeed a gray water recovery system. It's also very illegal. You can't just discharge effluent onto the ground. So it's not a good idea. I would not trust that the pipe goes anywhere. I think it's also reasonable to assume it's just clogged and you need to snake it or send a camera down there to see what's going on. Mike and Brian are both nodding. You guys think that's a good approach?
Yeah.
Yeah?
Yep.
Yeah.
Yep. Snake it. He mentioned that he vacuumed out the clog, but a small hole in a big plug could very easily draw enough air through to satisfy the vacuum, whereas it won't evacuate whatever that clog is. So the camera and the snake are good advice. The only other thing I thought is that it could be a venting problem, where you're trying to stuff a whole lot of water down a pipe, and if the pipe isn't vented properly, it can cause, if the air can't push all the way through, the air that's in front of this water plug, then the water plug isn't going to flow. You need to have a vent that's going to allow for the air that's in front of that slug of water coming out of the washing machine to be able to get out of the way. So there could be a problem there as well.
It's a lot of water that's coming out of a washing machine when it starts pumping out. You know, if you have a laundry tray and you plug up the drain, you'll quickly learn how many gallons of water it is. And this thing needs to be working flawlessly to handle all that water and the resultant air, as Mike points out, to go down the drain. Wow. Go ahead. You gonna say something, Mike? No. Andres, you have anything to add to this?
Yeah, I would definitely snake it because something similar happened to me last summer, where my main drain clogged, but we couldn't find it easy, and it was around the house, so I had to rent, one of those big snakes and actually get it from both sides, so from the clean out, and then I have another clean out close to the street, so I had to snake it from both sides to get rid of it.
I learn amazing new things about you all the time. Tell me what was that like, running that giant snake? Was that cool or was it disgusting?
It was disgusting, obviously, but I've done it. I've done it several times in my older buildings where I had to snake and actually get rid of a lot of, dark water.
Are there any tips to using that? I mean, it's stupidly heavy for starters, right? To get this thing down into the basement is no small task.
No, luckily for me, my clean out is actually right outside from the basement, so it's actually there. Like the cap was there. Luckily, the previous owner had some sticks that were pointing where they were, because it kind of happened to her before, I guess. So they had to actually replace an entire line and install a new clean out closer to the street. So that was the reason why I found the part of the yard not have planting. It was just a pile of dirt. So that's how I kind of knew what she was talking about when she told me. So it happened to me, but it wasn't snaked properly. So this time I actually snaked it through.
Is it immediately obvious when you're done? Does the machine make a different noise? Does it stop pulling stuff out? How do you know you've effectively cleared the clog?
So once you run it, you obviously have to fight it so it doesn't get twisted, because that's what you got to be careful too, because if you start putting enough force, it'll twist and it can actually rip your your fingers off. You got to be careful with it. So you don't have to point it, and then use different tips, because it comes with different tips. Like one just to penetrate, and then the other one to actually get rid of the clog, and then just run another one with a bigger one. But be careful with the pipes, because if it's PVC, you're gonna probably break the pipe, and then it'll just run through. It won't be enough force that you have to put. It'll just run through. Only on the corners when it turns, you might get confused with the clog. But that's why luckily I had 2 rains. So just one side and then the other one just coming back, and then just run water, put a lot of water in there and see how much time, track it. On the first time I put it there, it obviously stays, and then once you unclog it, you put the same amount of water and watch it just go. So that's kind of also you can tell like how if it's unclogged or not.
That's awesome.
Andres describing that reminded me of a clogging problem I had at my mother's house a couple years ago. The main drain from the house to the septic system is about 200 feet long, and it wasn't draining. And instead of using those commercial rental augers that go through and snake out the whole line, they sell these like for 10 or 15 bucks. They're like a heavy duty balloon, looks like a sausage, black sausage, and you hook a hose to it. It has a hole in the end, and you insert it into the pipe, and there's size for different size pipes. So in the clean out, I inserted that, and you hook it up to a regular hose with a water, regular garden hose, and you turn the garden hose on, and what it does is it shoots a spray of water. It doesn't move, but the balloon expands to fill the circumference of the pipe, the inside of the pipe, so that it forces a lot of water pressure that moves that clog through. So if it's just a sediment clog, it can clear out the line. So that might be something also that Evan could do too, to try to clear that line out rather than trying a snake. Snakes sometimes, especially the smaller ones, it's a little thin piece of metal, and you push it through and pull it back and forth, and it doesn't really open up the hole, whereas this one would at least get the flow going through and wash it, clear it out. So a couple of options there to check and see if you can clear that plug out, if there isn't a problem with that, if there's a dry well there that's just over saturated or something.
Evan, please keep us apprised of how you're going with your drain clearing, and if worst comes to worst, consider if you have to replace the line, pipe bursting might be a technology, and I'm trying to get an article on that. If any of y'all are listening and have experience or know someone who's done pipe bursting, I would love to talk to you about that for Fine Home Building content. Briefly, what you do is you send a cable, I guess, down the existing pipe that drags what amounts to a little cone, and it pulls plastic pipe behind it to replace the existing line without doing any excavation, except for where you start and where you end. You need a hole to receive the pipe on both ends. But it looks like amazing technology, and there's so much old plumbing in parts of this country that it seems like a very useful way to replace those pipes.
And it's called pipe bursting?
Yeah. And it's like Roto-Rooter type contractors who do this work, as I understand it.
Well, I've seen these ads recently here because most of the drains for people's houses run under the slab. So for those that were done in cast iron years ago, they've corroded out. And so they'll do just as you said, and it looks like it's a thin, almost like a fire hose that they pull through of PVC, and then they somehow expand it, and then it becomes the pipe. It's sort of a pipe liner. Is that what you're talking about?
Similar technology, Mike, but a little different. Yeah.
It looked interesting. Look, a nice way without having to jackhammer out your floor.
Oh yeah, and can you imagine when you're living in connected townhomes in Boston or Baltimore, or Well, it's been a great show, guys. Thanks for doing this.
Pleasure.
We should make mention to folks who are all access members. After lengthy conversations, we've decided to put the after show on pause. I'm not going to say officially that it's going to go away permanently, but we're going to try and do a better job of getting video on the Fine Home Building website and e-learning and other ways to engage our audience and teach them the important work about home building. And it's just been decided that we need more resources going to that. So at least for a while, we're going to hold on the after show. If you're an all access member, thank you very much for their support of the brand, and thank you for signing up for All Access. If you're not already an All Access member, I hope you'll consider it. There's amazing 40-plus years of Fine Home Building content on the website. It's arranged by category oftentimes and will help you do just about any home building or remodeling project you can imagine. So I hope you'll consider that. And I hope you'll write in with your feedback and letters, because it really is what makes the Fine Homebuilding podcast the show that it is. Do you guys have anything to add today?
Nope.
Keep craft alive.
Yeah, man.
Thanks for listening.
Indeed. Thank you all for listening. Unfortunately, that's all the time we have for today. Thanks to Mike, Brian, and Andres for joining me, and thanks very much for listening. Please send us your comments, questions, and suggestions to FHBpodcast at finehomebuilding.com. And please like, comment, or review us however you're listening. It helps other folks find the podcast. Stay safe, everybody. And what is it, Andres?
Keep craft
Amen.
alive.
Thanks for listening, everyone.